So welcome to class. Today, our target is we are going to review for that Unit C test. Remember, the Unit C test is worth quite a bit of your grade. It is something you should study for. The review I have should help prepare you. And if you forgot anything I'm about to cover, just as a reminder, if you go out here under last semester review videos, I posted the video I did for end behavior, which is on the test. I posted the video over multiplicity, which is on the test. Looking at the graph, talking about multiplicity, that's also on the test. Looking at a function and looking at the highest degree, and then determining how many total, real, and complex solutions there are, that is on the test. Being able to sketch a polynomial from an equation, that's on the test. You will have access to Desmos, so that makes that much easier. Factoring, so a lot of polynomials have a Gcf at the beginning. And then how to factor quartic trinomials, and also the stuff we covered this unit. So that was from last semester. We also went over grouping, and we also talked about factoring with complex factors. So here we are reviewing for the test. And then just so you guys see, the test will be on Friday or Tuesday. And actually, I should say Thursday or Tuesday. I'll fix that. But you're more than welcome to sign up for that test. How do you sign up for that test? You go in there, you click this link, and you schedule your test. Okay, so you choose your school, class is Algebra 2, and you go through that process. Okay. There's also a pre-test for Unit D you need to take. You could take that anytime on your own time. And other than that, I think it's important to know that on these 2 days, I will not be doing, and again, that should say Thursday, I will not be doing live instruction because I'm giving you the 2 days to take the test. So I will be available for a whole hour for office hours. And then starting, I think that'd be the 22nd, we will continue on with Unit D, and we'll cover Unit D. So let's go ahead and get started. I made a review. The review is there to help you be more successful on the test. We're going to go over quite a bit together. And so if you go out there, that's all you're responsible to do today. I will try my best to do it all for you, but we'll just see how it goes. So you go out there, click. There it is. I did print it off, so I'm going to use my print off. Here we are. And remember, you have access to Desmos. So at any time, if you need to use Desmos, feel free to. And these are all screenshotted problems that we have done before. So that's why it's kind of out of order. It goes from number 8 to number 1. I do know how to count. I was just screenshotting here. So on number 8, so determine the number of total zeros, real zeros, and non-real zeros. Okay, so when I look at this, and it's kind of hard to see, but it looks like, and it doesn't even say to say what the zeros are, it just says how many. But notice there's a 0 here. That's 1. There's a 0 here. That's 2. And then there's a 0 here. So this one has, and actually you could have just looked at the function. This is x to the 3rd. By the fundamental theorem of algebra, whatever the degree is how many solutions there are. Those could be all real. Those could be complex. They could be duplicates. Remember, if they are complex always come in pairs. So if I have 2 to the 3rd power, then you should pick 3 total zeros. Now, when you look at the graph, it clearly crosses 3 times. So that means there are 3 real zeros. So that leaves none that are complex or non-real, same thing. So that would be 0 non-real solutions. I'll call them zeros, but zeros and solutions are the same thing. So 3rd power means 3 total. It crosses 3 times, so all 3 solutions are real. On number 1, and we spent time on this, in behavior. Remember, in behavior, what you're looking for is this notation, and it's as x approaches the left, what does the function do? So that says, as you go to the left, and then you're going to say, does it go up or down? And then you also need to talk about the right side. So as you go to the right, what does the function do? And you're also going to put, does it go up or does it go down? So remember, first thing to do is to identify the leading term. The leading term would be the term with the highest degree. 5 is the highest degree. I'll go ahead and just circle that. If the number in front is negative, then that means it opens down on the right. This would be on the right. If that was a positive 2, it would open up on the right. Now, where does it talk about the right? It talks about the right here. So as you go to the right, the function goes down. So you would put negative infinity. From there, you look at the degree. If the degree is odd, you do the opposite on the left. And if it's even, you copy down the same thing. So ours is 5. 5 is odd. So if it's going down on the right, it's going to go up on the left. So you would put positive infinity. Okay. So what that means is that it's going to open up on the left. So if it's going up, you put positive infinity. If it's going down, you put negative infinity. Next one. Describe the right and left-hand behavior. So the first part's going to be the same. So you're going to talk about the left and the right. So you're going to say as x goes to the left, what does the function do? Notice our function is called f of x on both. That's why I'm using f of x. So the function does what? And then as you go to the right, what does the function do? You identify the leading term. It's usually the one in front, but not always. It's the one with the highest degree. Remember, degree is your highest exponent. So it'd be this one. You look at the number in front, it's a 1. 1 is positive. That means it goes up on the right. So you're going to put, because it goes up on the right, and this is as you go to the right, you're going to put positive infinity. And then you look at the degree. If the degree is even, you just copy the same thing. If it's odd, you would put negative infinity. 4 is even, so if this is infinity, that's also infinity. Now, if you don't remember the rules, remember you have access to Desmos. You could just type this in without the f of x and then see what the picture looks like. And you'll see it goes up on the left and on the right, so that means you put infinity for both. So that's one thing you could do in case you're confused. So that's the first part of the test. Another part is looking at a graph and being able to answer these questions. And I think I'm going to go through them one by one for each. So the first question, is the degree even or odd based off the graph? Okay, so here we'll do it like this. Blue. That's actually pretty easy. Okay, even or odd. Whenever they go, see how this one goes down and this one goes up? Anytime they do the opposite, then we call it's odd. It has to be odd degree. So for number one, we would say odd. For number two, see how they're both going up? Anytime they're both doing the same thing, it's even. And then the third one, we have this one that's going up to infinity, and this one that's going down to infinity. So anytime they're opposite, it's odd. So that question isn't too bad. If we had one that was going down and down, we would also say even. Two, is the leading coefficient positive or negative? So you may be asking, what do you mean by leading coefficient? Leading coefficient is the number in front. So the leading coefficient here, and it's not always the one in front, but usually it's the one in front of the highest exponent. So we would say the leading coefficient's -2, which is negative. The leading coefficient's 1, which is positive. So that's what they're talking about. Is the leading coefficient positive or negative? Well, if it opens up on the right, which this one does, then you say positive. If it opens up on the right, which this one does, you say positive. And if it opens down on the right, like this one, you say negative. Okay, so that's question number 2. Question number 3, describe the end behavior. So you would say, as x goes to the left, what happens? Now these don't have names, so I'll just call it y, or you could call it f of x, I guess. What does the function do to the left and the right? And I'm going to do that. Just give me 1 second. I'm going to copy this down. The same thing. As x goes to the left, what does the function do? These don't have names. Nope. And as x goes to the right, what does the function do? And then on the third one, again, notice the first part's always the same. As you go to the left, what does the function do? And as you go to the right, what does the function do? Now it's very easy when you have a graph. So on the right, what's it doing? It's going up. This is infinity. So you would copy down infinity on the right. This one's the right. Okay. What's it doing on the left? Here's the left. That's going down, so that'd be negative infinity. So you would copy down negative infinity. So notice if you have a picture, this becomes very easy. Here, this one is infinity on the right, infinity on the left, because they're both going up. Up is infinity. So I'm going to put on the left, infinity. On the right, infinity. This one's going up, infinity. This one's going down, negative infinity. So what's it doing on the left? Well, this is the left. It's going up. What's it doing on the right? It's going down. So negative infinity. All right. We're getting there. Number 4. Write an equation that could represent the function. And remember, if you type in a function, you could type it into Desmos real quick and see if it matches up, kind of. And remember, these aren't going to be exact functions. They're functions that could be it. So this is when you start thinking about, does the graph go straight through? Or does it squiggle? Or does it bounce? Remember, if it bounces, it happens twice. So what do we call a squiggle? This is what we call a squiggle. And so I kind of have to guess that's negative 2.5. So that's going to happen 3 times. Remember, squiggles happen 3 times. So I have that one that happens 3 times. I have this one that goes straight through. And I have this one that goes straight through. When it goes straight through, it happens once. All right, so the solution here is 0, so the factor would just be x. The solution here is 1, so the factor would be x minus 1. And this one's kind of tricky because it looks like it's halfway between negative 2 and negative 3. So it'd be negative 2.5. So on there, that actually makes 2x plus 5. Because if we solve 2x plus 5 equals 0, so if I were to solve that, I would subtract 5 from both sides, divide by 2, and you get negative 2.5. So you kind of have to work backwards. Okay. And notice that happened, it's a squiggle, so we say it happened 3 times. So what would my function be? I'd have 2x plus 5 3 times. Why 3 times? Because it's a squiggle, for lack of a better word. And then here's x, and went straight through, so that happens once. And here, it went straight through, so that happened once. And we're done. Now remember, the order does not matter. So if these are out of order, it's fine. Now, it's not a bad idea to type that in and make sure it looks kind of the same. Let's see. Don't really have time, but I think it would be good to do. Desmos. It's never a bad idea to check your work. So I think it's going to be 2x plus 5 to the third times x times x minus 1. Now, it's not perfect. Because you have to mess and kind of make it not so skinny and change the coefficient to make it wider. But just based off the zeros alone, this could be. So we have a squiggle there, a 0 there, and a 0 there. But notice it has the same characteristics. All right, next one. We have a squiggle. What's a solution for minus 1? The factor would be x plus 1. Because it happens, because it's a squiggle, you should put a 3 on it. Here, the solution is 2. So the factor would be x minus 2. Remember, if it makes a bounce, you put a 2 up there. That could be bouncing underneath or above. We call that a bounce, for lack of a better word. And then here it goes straight through, and that's 4. So the factor would be x minus 4. And so you put all that together, and I would have x plus 1 to the third. I would have x minus 2 squared. And then I would have x minus 4 to the first. Okay. Next one. My solution is here at negative 2. If the solution's negative 2, the factor is x plus 2. It goes straight through, so it's going to be to the first. Here, it looks like my solution is negative 1. If the solution's negative 1, the factor is going to be x plus 1. And it looks like it goes straight through, so it's going to be to the first. Here I have a solution at 0, and it makes a bounce. So because it makes a bounce, it's going to be to the second. This is x equals 0, so that would just be x. And because it's a bounce, it's going to be x squared. Here we have 2. The 0 is 2. So the factor would be x minus 2. It goes straight through. So number 4, putting all that together, I have x plus 2, x plus 1. And again, order does not matter. I have x squared, which is usually at the front. And then I have x minus 2. Now, something that's kind of interesting is because it opens down on the right, all of these are positive in the front. So technically, you need to put a negative out there to make it go down on the right. Otherwise, everything would be the same but opposite. And if you're not sure, you could always use Desmos. All right, that question took a little bit. And again, I'm trying to go through as many of these as possible. Number 1, and again, this is from homework, so that's why we're back to number 1. Determine the number of total zeros, real zeros, non-real. First thing I might do is, this is what they want, so I'm going to fill that in. Total zeros, and then how many real zeros, how many, and non-real zeros. I would type this into Desmos real fast and go look at the picture. Let's see what this picture looks like. X to the third minus 5x squared plus x minus 5. Okay, so it's to the third power, so it's going to have 3 total solutions. Here's my real one, so I have 1 real, and notice it never crosses again. So by the fundamental theorem of algebra, you must have 3 solutions. This one has 1 real and 2 imaginary. So on my paper, I would say third power, 3 total. There was only 1 x-intercept. That leaves non-real of 2. These 2 numbers should add up to this number. Non-real will never be odd. It must always be even. So you can never put 1 here. You can never put 3 here. You can never put 5 because non-real solutions come in pairs. Next one. Total zeros. That's easy. I don't even need a picture for that. That's the highest exponent, so it'd be 5. And then how many of those are real? And how many are non-real, which some people call those complex. Let's go look at the picture. Let's see. X to the 5th plus 3x to the 4th minus 8x to the 3rd minus 24x squared. There's a lot going on here. Oop. Minus 9x minus 27. All right. So looking at the picture, I like to zoom in and out. So we have one real here. This is a bounce. So we count that as twice. So we have 2 real, 1 real. That makes 3 real, but I need 5 total. That means the other 2 are imaginary. So I got 3 real, 2 imaginary. So on my paper, because of that bounce, we count it twice. I would say 3 real and then 2 imaginary, or complex, or non-real, all the same thing. Number 3, total zeros. That's easy. Highest exponent by the fundamental theorem of algebra is going to be 3. How many of those are real? How many are non-real? Go type it in, see what it looks like. Ooh, type that in right? Okay. Well, looks like it crosses through, so there's 1 real. We're looking for 3 total, so that means the other 2 are non-real. So we got 1 and 2. What's important at the very end, these 2 numbers should add to this number. This number comes from this number. And notice non-real is never odd. You will never have an odd number there. So if you're taking a multiple choice test and they say 3 non-real zeros, that cannot be true. So you can cross that one off. All right. So I have 6 problems that I very much would like to factor for you. I am going to post this recording. I know it's close to the time that I usually say we're done. This is one of those things I think it's better to just keep going. If you need to sign off, feel free to. It's okay if you want to sign off now. But I am going to go ahead and finish these 6, and I will be posting the video out on Canvas. So that does mean I will be a little bit late to my office hours today, but I do think that it's important that we factor these 6 because factoring is on the test. Okay, so I probably just need like 10 more minutes, I'm going to guess. So again, if you need to sign off, go ahead. I won't hold it against you. The key when you're factoring, first thing I would do is get everything to one side. This one, everything's to one side. This one, everything's to one side. Here, everything's to one side. This one, 9x needs to come over. Let's do that real fast. And technically that would be equal 0, but we're not solving these, so I'm not going to worry about it. Here, I need to get both of those to the other side. Remember, if you bring it to the other side, it changes signs. So that'd be minus 11x cubed minus 14x squared. Here, and again, you may be asking, why didn't you move that one to the left or to the right? I didn't move this to the right because I don't like dealing with negative numbers in the front. I like to keep that first number positive whenever possible. So like here, which one do I move? I'm going to move this one over to keep the x to the fourth positive. So this is going to be x to the fourth minus 81 x squared. Now from there, you should look for GCFs. So let's go through every problem. GCF in all of these? Nope. GCF in all of these? Nope. Here is there a GCF? Yeah. 6, 10, and 5 are all relatively prime, but they all have an x. So let's factor it out. Is there a GCF here? They all have an x. And 36, 6, and 9, the largest number that goes into 36, 6, and 9 is 3. So I'm going to take out a 3x, which leaves 12x squared plus 2x minus 3. And again, I'm not done with these. I'm just doing GCF first. Here, do they have a GCF? 15, 11, 14? Not with those numbers, but they all do have an x squared, so I can factor it out. And I know I'm going through this part a little faster. We've already covered this kind of stuff. Here, is there GCF? Yes, they both have x squared. All right, so I did the GCF of everything. From there, this is a quadratic, so let's go ahead and factor it. This is a quadratic, so let's go ahead and factor it. That's a quadratic, let's factor it. And then this would be difference of two squares. So this one's probably the easiest. Two numbers that multiply to x squared, x and x, multiply to 81, 9 and 9. So you put x plus 9, x minus 9. Remember, if that was plus 81, you put plus 9i minus 9i. So number 14, this one's done. We're done with that one. Okay, it's factored. These are all quadratics, and they're going to take me a little bit because anytime there's a number in front, you have to take 6 times 5, that's 30. You want it to add to 10. So that multiplies to 30 and adds to 10. Let's see, 2 times 15, no. 3 times 10, no. 4 doesn't go into 30. 5 and 6, no. 8, 9, 10. Well, there's nothing that multiplies to 6 times 5, 30, but adds to 10. So this one is done. Okay. So we can't factor that one. So this one's done. Done. Here, again, when it's a quadratic with the leading term besides 1, you take 12 times negative 3. That's negative 36. You want that to add to 2. So what multiplies to negative 36 but adds to 2? 1 and 36, 2 and 18, no. 3 and 12, no. 4 and 9, no. 5 doesn't go into 36. 6 and 6, no. Another one. Usually this factors, but it doesn't factor. And I wouldn't really call this cheating, but you could, if you're not sure, you could just go type that part in and see if it factors. Let's see if it factors by looking at Desmos. Now, I really don't want you to get into a habit of factoring this way, but it does work, where you just type in, then you look, and you're like, well, 0.424, so that's part of why it didn't factor. negative 0.59. That's why it didn't factor. But let's say that was negative 1, which it isn't. Then your factor would be x plus 1. And let's say this was positive 1, you would say x minus 1. So that's one way. You could always use the zeros to help you factor. But it doesn't factor, so we're done. $13. I'm going to take 15 times negative 14. (15 times negative 14), negative 210. And it needs to add to negative 11. Oh boy. I might help me figure it out. I might go type that into Desmos real fast, which I am, because I can't think through that really fast. And I didn't work through all these beforehand. So let's see. Yeah, so that's not going to factor. Just, I mean, it's not going to factor. I mean, that's negative 2/3. Actually, negative 2/3 would factor. Well, maybe it does. I guess I'll have to take a second, see if you figure it out. What multiplies to negative 210 adds to negative 11. Let's see. Negative 210 divided by 2, that doesn't work. Divided by 3, doesn't work. Getting close. Getting there. Divided by 9, maybe. Oh, that was easy. Negative 21 and 10. Negative 21 times 10 is negative 210. Negative 21 plus 10, negative 11. And then from there, remember you do your x minus 21, x plus 10. And I'm going to ignore the x squared for now. And then you divide them both by 15. You reduce and then slide. 21 over 15, let's see, 3 goes into both. So that'd be 7/5. So then the 5 slides to the front, that'd be 5x minus 7. Here, 10 over 15, 5 goes into both. So that'd be 2/3. So then the 3 would slide to the front, make 3x plus 2. Which is where the negative 2/3, negative 0.6666 came from. And then pull down your x squared. So this one's factored. We're done. All right. These won't take long. On these, remember if they have 4 terms, you should break it in half. You look on the left, what do they have in common on the left? On the left, they both have a 2x. What's left over? That'd be 6x squared plus x. No, that's not right. Ooh, almost messed up. They both have a 2x squared. So then what's left would be 6x plus 1. Remember, anytime there's a negative, you pull it down. What's the GCF of 30 and 5? 5. Negative 5 times what is negative 30x would be 6x. Remember, negative times positive is negative, so this must be a positive. Negative 5 times 1 is negative 5. Those should be the same, which they are, so I factored out. If they aren't the same, I can't go any further. And then normally you would factor this. When there's a number there, you don't usually factor it. But if that was x squared minus 5 without the 2, you put x plus square root of 5, x minus square root of 5. Okay. And then finally, our last one, break it in half. Look on the left. What's the GCF between those two? 8x squared. What's left over? X minus 8. Here, what do they have in common? Nothing besides 1. 1 goes in x, 1 goes in negative 8. So I just factor out the 1. And notice I pulled down the plus. Because I didn't change anything, it stays x minus 8. Notice I have the same term, so I put x minus 8. And then I have 8x squared plus 1. And then sometimes this factors more. All right. So yes, that did go 10 minutes over, but I hope that helps you guys be successful on your test. I am going to sign off. Hope you all have a great day. Bye-bye.